Hey, welcome everyone to another Data Science Club video. And today we'll be continuing with our geospatial analysis notebooks. Um, if you guys haven't seen the previous videos, please go ahead and pause this video and go to the previous videos for geospatial analysis. I think we have 3 parts before this. This would be the 4th part. So in our first 3 parts, we completed the first 2 exercises, your first map and coordinate reference system. And the next thing that we are going to go to is interactive maps. Interactive maps basically means that you can zoom in and zoom out of a space and actually go ahead and interact with the map itself. And again, this exercise is on Kaggle. If you just go to kaggle.com, you should come to the homepage, then go to courses and search for geospatial analysis there. And then you should come to different lessons. And if once you have gone through our first 3 videos about geospatial analysis, which would cover these 2 topics, then you can come back to this video and we'll talk about interactive maps over here. All right. And like always, we'll go with the theory part first, the tutorial portion, and then we'll go to the exercise sections. Yeah. All right. So basically, this is the tutorial portion. And in this tutorial, we are going to learn how to create interactive maps with the Folium package. And we'll be visualizing Boston crime data. Interesting. So it's Folium is a Python package. You import it, and you have Choropleth, circle, marker, heat map, marker cluster. You're getting all this information from the Folium package, or all these different functions from the Folium package.
Yeah.
So then you create a map, and zoom start is at level 10, and then you display the map. Location sets the initial center of the map. So whatever the coordinates that you specify, that's going to be the center. And I think it's somewhere in Boston, downtown area where this coordinate should be. And tiles changes the styling of the map. And over here, the map that you're seeing, that's an open street map style. And there are some other options if you guys are interested.
Oh yeah. Looks like there's 10 different options in there.
Yeah. I mean, watercolors, cartoon, positron.
Oh, well, there might be different styles for different types.
Yeah.
Anyway, yeah, that's cool.
And then you start the initial zoom level. And once you have the initial zoom level, you should be able to just kind of zoom in or zoom out of the map to get more details about one place. All right, the data. So now we'll add some of the crime data to the map. And we are not focusing on the data loading step. And we have this data frame, pandas data frame called crimes, where we have all this data.
Mm-hmm.
There should be some coordinate system over here. Yeah.
There it is.
So
you
have latitude, longitude, or the location, and which you can use to plot.
Mm-hmm.
So to reduce the amount of data we need to fit on the map, we'll only confine our attention to daytime robberies. And it's basically offense code group robbery, and R is in 9 to 18. That's like 6 p.m.
Yeah, 9 a.m. to 6 p.m.
And
I wonder how it knows what time zone.
yeah, I think it might depend upon the data.
Yeah, if this data frame is specific to Boston, then it's probably already in the right time zone, if I had to guess.
Yeah.
And then we probably don't need to worry about that. But that is something to consider if you're doing like a larger map.
Yeah. And basically, so folium.marker, you specify the map, and for index comma row,
Mhm.
and you're just adding it to this map and you display an M2. And once you plot the map, you will see all those spots where the daytime robberies have happened. That's a lot of daytime robberies.
Well, it might seem like it. I don't know. It probably is, but like it depends on over what time period. I
Yeah,
guess
it
if they're
looks.
all over a day, that'd be a ton. But if they're all over 10 years, it's not quite so bad.
Yeah.
I mean, let's be real though. Any amount of robberies is too many. But you know, there's some very wiggle room in there for what I might call too many. What I might call like a lot.
Yeah.
I don't know. We'd have to investigate, right? So that's what we do. Anyway.
Yeah, and you can see how much area is considered actual Boston. So it looks like it is involving some of the suburbs, if I'm not wrong.
Yeah. Look, it
Not
looks that
all.
way. I mean, yeah.
All right. So marker cluster. If we have a lot of markers to add, you can use marker cluster to declutter the map, and each marker is added to a marker cluster object. And this is how you can actually show it. So you define folium.map as M3, then you add points to the marker cluster. So you specify MC equal to marker cluster for index or independent properties. And then in the cluster, you're adding different points. And then you add those child and
Oh, I see. We're
and
adding them and then letting
yeah,
it do its thing. Okay.
yeah. So basically, like all of them combined. So this area has 96 of those marker points, but all of that is combined into one single block till the time you zoom in. As soon as you start zooming in, you'll see that it divides into different groups, and even this one has two different robberies that are marked. So if I zoom in on this, you'll see that it has two different marker points inside it.
Yeah.
So it's basically, it's basically decluttering the map visualization, which is not a bad idea, especially seeing the first map that we saw.
Yep. Yeah. It appears to be distance based too. Well, visual distance based. So the more you zoom in, the further they get apart and the less it clusters. So
Yeah,
which is cool. That's very interactive. It's awesome.
yeah. And so the next one is a bubble map. A bubble map uses circles instead of markers. You can also show the between locations and two other variables. So the way of achieving this is M4 folium.map and define Colorproducer.
Oh, okay. So it's a function that you give it a value and it gives you a color.
Yeah.
Okay.
I'm wondering where it is getting this value from.
Oh, I think it's just a function you're passing in.
Depending on
that function to make a decision. Yeah.
So depending on at what time it is happening.
Right.
So anything that you see in green that happened before noon, and everything in dark red is after noon. Yeah, after 12 p.m. till 6 p.m.
That's cool.
And basically you are specifying and range circle. So you're specifying location, daytime robberies, location, and then the color that the dot is supposed to be. And this is another method of sort of decluttering the
or at least distinguishing, trying to find patterns maybe.
Yeah, sorry, I was just trying to see if I click on one of those bubbles, if it shows up what kind of robbery it was and when it happened and all that stuff, but it doesn't.
Yeah, for those of you at home, if you want to try, see if you can get this to interact with the clustering.
Yeah.
See if you can make that happen.
That would be awesome.
Yep.
All right, so the next one is to create a heat map. That is actually a pretty good idea to see where in the Boston suburb you will see. So like this area seems like there are a lot more robberies over here, this area, and a bit of this. And it seems like just creating a heat map is simple enough. You just specify heat map, data
Mhm.
is to clients, and you add it to M5 or whatever is the base map that you have created.
Yeah, it's probably like a Gaussian kernel sum or something, or a radial basis function or something like that. See that all the
Yeah.
time in other things, other fields. That's really cool though, that it kind of does that. I definitely don't like the color map choice. I would choose something a little more readable.
Yeah. All right. So the two things that we have in heat map are data.
Mm-hmm.
Is a data frame containing the locations that we'd like to plot. So basically,
Yeah, we
we
selected
are,
just that one.
yeah, just a subset of that data frame. And then the radius controls the smoothness of the heat map. So higher values make the heat map look smoother, that is with fewer gaps.
Mm-hmm.
Okay, this is something that we can try out and see
Yeah, that
how
one
it
looks
would look.
neat.
Yeah. All right. So to understand, so next we are going, so till now we have been looking at, what was the one that we looked at initially? Uh, actually, so the one that we have been looking at is OpenStreetMap, and now we are coming to Choropleth Maps. I think that is another, maybe not. Maybe it's just another type of map. All right, so we read the file with police district, uh, and then we define districts, geometry, and we also create a panda series called plot district, and that shows the number of crimes in each district. So D4 has this many crimes, B2 has this many, and all the other stuff. You define folium.map, and this is Carto DB positron. This is the new type of map that we are seeing. And with Choropleth, we define geodata, that is districts, the data that we are supposed to show over here. I'm not sure what does this one fill color mean?
It's yellow, green, blue,
Oh,
and I'm not sure what that comes from, but it sounds like it's from Jan Brewer's color stuff.
yeah. So basically, it's just a scale of how many robberies are happening per police district, and it looks like southwest.
Yep, there it is. I found it. We'll share a link to the Color Brewer website later. It's colorblind safe color map. Colors for maps, basically. That was devised quite a while ago, like 20 or 30 years ago. So
All right.
we can put that in the
Yeah,
video.
so it basically looks like it's the southwest portion of Boston suburb. Seems like it has the most daytime robberies or robberies. All right. So next we can just go to our own exercise. I'm going to leave this open because a lot of times we have to come back because we just saw a lot of these functions. So
Yes.
we might have to come back to, or we will have to come back to actually take a look at them and complete our exercises. All right, let's see. So if you haven't used exercises in Kaggle before, the first block that you see, it basically imports all the libraries that you're going to be needing throughout this notebook. And there are also some helper libraries that seems like they're just developed for Kaggle, which allows them to provide hints to different blocks. or provide solutions for different blocks, and also allows them to check whether the part of the code that you have written is correct or not. So let's see, we'll just run this. And this is basically where we define a function for displaying interactive maps. It accepts two arguments: the variable containing the map and the name of the HTML file where the map will be saved. This function ensures that the maps are visible in all browsers. All right. I don't know. All right. So the basic exercise is, do earthquakes coincide with plate boundaries? Run the code cell below to create a data frame, plate boundaries, that shows global plate boundaries. The coordinates column is a list of latitudes, longitude, locations along the boundaries. And this is very similar to something that we just did, I think, in the first exercise of geospatial analysis. All right, next run the code cell below. All right, so it shows all the plate boundaries on the in the world and defines the coordinates for them. And next run the code cell below without changes to load the historical data. It's basically again reading the CSV file, and then we're just going to see the first 5 elements. All right, so we have latitude, longitude, depth, magnitude, and the stations and whatnot. So the code cell below visualizes the plate boundaries on a map. Use all of the earthquake data to add a heat map to the same map to determine whether earthquakes coincide with plate boundaries. So we have M1 equal to folium.map, and we are getting Carto DB positron kind of map. Zoom start equal to 5. And we are basically just adding a heat map to the map. So for doing that, we're just going to rely on this. So first of all, we are adding it to M1 because that's the map that is being created. And the next thing that we are doing is we are defining data is earthquakes and
full latitude and longitude instead of lat long.
Yeah. So latitude and longitude. And that should be it. And here is our embedded map. It kind of follows, let's see, let's scroll out. All right, yeah, now we can see. So you can see that the heat map is basically right along the fault lines.
Yeah, very much touches them for the most part.
Yeah, apart from this one. Let's see if that was correct. Thank you for creating a map. And we can see that the heat map actually touches on. We can try to make it a little less
smooth.
Yeah. So let's just go with 1. Apparently 1 doesn't show much. Okay, 5 is still showing. I mean, it's like in spots rather than looking like an actual heat map. What happens if we increase it from 5 to 20? Would it be too smooth? This one actually shows a better view, I would say.
Mhm.
So it also shows that the more closer you are to the fault lines, the bigger, the chances of bigger earthquakes are higher. And as you go a little farther off, it's mostly a green kind of, or basically showing there are a lot more earthquakes happening closer to the fault line. As you go farther off, it starts decreasing the chances of earthquakes.
Well, and my understanding is the Indian sub plate is moving northward, and
Yes.
depending on how they meet, that plate may be causing earthquakes under the other plate, because that may be
Yes.
where the friction's happening. So
yeah. I mean, the Himalayas are made because this Indian subcontinent plate is actually moving up, and so all the earthquakes are happening over here in the Himalayan region just because of that movement.
But like with Japan, it's this kind of plate. So so they happen right on the fault line or really close to it. Anyway. Or that's my understanding. I don't know. It's just interesting. That's really cool.
Yeah.
I'm no geoscientist.
All right. Yeah. And if anyone has better answer why some of those are just directly on, all the bigger earthquakes and more frequent earthquakes are directly happening on the fault line. And over here, it seems like a little bit above rather than directly on the fault line. So somebody has a better answer. Definitely let us know.
Oh yeah, I'd love to learn.
All right. So is there a relationship between earthquake depth and proximity to a plate boundary in Japan?
Oh, that's kind of like what we were just talking about a little bit.
Yeah. So you recently read that the depth of earthquake tells us important information about the structure of the earth. You are interested to see if there are any interesting global patterns, and you'd also like to understand how depth varies in Japan. So we are trying to add a map to visualize earthquake depth. I'm wondering which one is the best. Is it again going to be a heat map, or heat map doesn't look like the best?
I don't think that's the best one. Maybe
the bubbles.
Yeah, probably the bubbles, and then just give it like a continuous color. We could do discrete or continuous or whatever. I don't think it's particularly checking that kind of thing. I don't know what it's checking, but it's probably not checking. Oh, they did it exactly right.
Or it could also be this. The Choropleth.
Maybe what kind of data does that need? We scroll up just a little bit. What kind of data is it getting? No, the Choropleth one. If you scroll back down just a little, what is it asking for?
So it's asking for a GeoJSON feature collection containing the boundaries of each, or it's asking for boundaries.
Yeah, I don't think we have any boundaries. So I don't know if that's going to work.
Yeah.
At least not yet, anyway. Well, I guess we do the faults, but we're not trying to plot that right now. We're trying to plot the. So we might, yeah.
Yeah. Is there something that we can add over here rather than Colorproducer?
No, we could probably just do a Colorproducer, but we might have to be more careful about it. I don't know. It seems like a lot of work, though. I wonder what they're. Usually these are simpler, so I don't know. We may have to try different things and see what works. This is I mean, this is what data visualization and data science are like anyway. It's not, here's my answer. It's what would work best to get across what I'm trying to do. To get my message across.
Let's see.
So if you're having to think about this kind of thing, you're probably doing it right. If you have an instant answer, maybe you're maybe you need to spend just a teensy bit more time thinking about alternatives. Yeah, we don't have to necessarily do it that way. I mean, I don't know if I'd do it discreetly. I'd do it probably with a continuous.
Yeah, I think so. I mean, but that's why I was wondering if the colors has a parameter that we can use that is going to be a continuous.
What? Can you? Oh, I guess I could pull it up. I'm gonna look up the API for it and see if I can find anything. But that may take a minute, so feel free to continue. Oh yeah, we might just be able to give it a color, like the yellow, green, blue thing. I mean, that is a potential. Instead of color equals color producer, just give it color equals and then a color map that it knows. And Python has a lot, so let's see.
All right.
Yeah, because I don't think we need that part.
Okay, so for I in range 0, comma length of okay,
maybe we should do magma.
Yeah,
seems appropriate.
Earthquakes, where is that?
Plus it's a decent color map anyway, so
yeah,
not the best, but pretty good. Well, and when I say the best, I'm thinking from a scientific perspective. It's pretty good.
All right, so Earth.
And we'll talk about this at a future date.
Yes, definitely.
Using good color maps and things like that. Color maps that don't interpret the data for you and such. We'll get there. We'll get there. Let's see. Yeah, just literally put in, the string magma and to replace all of that.
All right.
Yeah, you don't need to do the add to thing, I don't think.
Oh, we do need to add to M2, right?
Oh yeah, that's true. Then maybe we do need a color producer. Now I'm not. You raise a good point, because how else is it going to know what the data? But it shouldn't need to know what the data is, right? It should just need to know. So hold on, I'm going to put it. You would just replace everything after that with, like, literally just double quoted string magma.
Yeah.
I don't think you need to add anything to the map per se, color wise, because I think that's what the circles are going to do anyway.
Yeah.
Unless I'm horribly misunderstanding this, which is, it's possible. How we learn.
Where did I leave return probably? So yeah.
Oh yeah, that too. But also under the color section, it's not going to work because you got an issue under color. So just literally just replace the whole thing with. Well, but yeah, that's a good point. So I think we might need a color producer.
Can we use this YL?
I don't know that we can, because we're creating circles one at a time, and we're telling that circle, hey, have this color, right? And so I don't think we can do that.
Okay. Yeah, I think we might need that then.
We don't necessarily need a color producer. We just need to pull a color from somewhere. And I guess the color producer is a one way to do it.
Yeah, because we do want to show depth, right? So
yeah,
technically we should have different.
Oh, we don't need it inside the. Oh wait, yes we do. Sorry, I thought you put it somewhere else. Yeah, no, you're fine.
So 31, 8, 173.
Well, you can also do min and max, right? That would probably get us a range. You'd have to do it in a new cell somewhere.
Yeah.
I'll be able to do it on my one.
Yeah. All right. So min is 0 and max is 688. So if value is less than equal to 100, return forest green, else return dark red. We'll see how this one
Yeah, and we
looks.
gotta fix the line that we had before. Yeah. I mean, this is one way to do it. This is probably not the best way. There might be better options.
Yeah.
There are almost certainly better options.
Yes, because this one is still very, I mean, either you define a lot of sections over here, so that value less than equal to 100 is for a screen, then less than equal to 200 is something else, then less than equal to 300, where you're defining your own range.
You could also build an interpolation function as well.
Earthquakes, and this would be is it not depth? Oh, uppercase D. Right. All right, so the red ones are everything above 100.
Yeah, so deeper ones, yeah.
And anything less than 100 is over here.
Yeah.
So it looks like less than 100 are pretty close to the fault lines.
Mm-hmm.
All the greater than 100 are. Do we see the same pattern everywhere? Or yeah, I don't see a lot of reds actually.
I mean, I guess deeper than 100. Well, we could probably play around with this and figure out the we could do like a 1D histogram and figure out the distribution of depths and all that kind of stuff. Or we could build a continuous color map, but we don't need to spend all that time right this second. Yeah, I'm curious what their solution is.
Yeah, I want to see what they. Yeah, they used Colorproducer.
Okay,
and
they just split it up a little different. Yeah.
Yeah, so they had 50, 100, and everything above. So we just went with 100. I don't know why I chose 100, but that seemed like a good number.
I would probably pick a sequential color map and then just interpolate into it based on, I normalize the 0 to 688 to 0 to 1 and then interpolate into a color map. And that way I'd have a continuous color value. That would be what I'd do. But, that's going to take a little more effort than we have time for right this minute. So.
Yeah. Let's see.
So that would be maybe something people at home could do.
Yes, definitely. Orange. Else. Let's see what.
Oh, Elif.
Yeah.
Okay, we did it apparently. Where'd it go? Oh, there it is. Okay. I was like, wait a minute.
It's not giving any more insight than what we gathered from the previous map.
Yeah, I mean, there's a lot more overlap between the 50s and the 100s.
Yeah.
Or the zeros and the 50s. Yeah, those two breaks. Right. Anyway, okay. That's cool.
All right, which prefectures have high population density? So this one contains the geographical boundaries of Japanese prefectures. So Let me see if I'm. Prefecture was state. What was that?
Yeah, it's like you could think of it like a state. Probably not a perfect definition.
Yeah. All right. So we have read what are the different prefectures. The next code cell creates a data frame stats containing the population area, and population density for each Japanese prefecture. Okay, so we have three different columns over here, one for population, one for area per square kilometer, and the density. So we want the Choropleth maps to visualize population density.
Okay. All right.
All right. So this one is already given. Now we need to create a Choropleth map. All right, so we have M3, so this should be added to M3. Geo data is
Prefectures, I think, isn't it? Or
yeah, prefectures.
Yeah. It's weird that we're passing it a internal function though.
Yeah.
That strikes me as a little bit odd. I feel like there might be a better way to do that, but or at least a more API friendly way.
So data equal to stats and key on density. Population density. All right, I think that should be it. What's different over here?
Let's see. Green, blue. What does it say? What does the error say?
Oh, it says.
Let's see, none type object is not subscriptable. Okay. In legend name. That's weird. Or after or somewhere in there.
So key on density. It is density.
Oh, no, never mind. I thought I saw something, but never mind.
Geo data is prefectures.geo interface. It is prefectures, right? Yeah.
No, apparently the double underscore geo interface thing is the preferred way to access it. So
yeah,
you can also do iter features, but anyway, it's neither here nor there. Okay, yeah, I looked it up in the API. As for this, let's see.
Oh, prefectures geometry. Why do we have to specify geometry?
Oh, is it? It must be a row of geo interface things or geo. That's weird. Let's scroll down. What does it say? Solution? Yeah, you also need to key on feature.id. I don't think that changes. At
And
least for the
details
purposes.
only stats
Density, right?
Yeah.
Yeah, okay. I guess that's, oh, you have too many E's.
Yeah.
Okay. Picture. And I think you need the, yeah, you're good to go. Hopefully. Probably.
Yeah, that looks like it's creating a map. All right, so population density. It seems like everywhere it is 71 to 1250.
Yeah, except Tokyo.
Yeah.
Yeah,
Tokyo is like more than 7146, so it's way more than 7146. There should also be Osaka.
Yeah, you got
There is
Yokohama.
Osaka.
Yeah, Osaka, Yokohama, and should be one or two others, but maybe not. Maybe I'm mistaken. Oh yeah, Nagoya. Yeah, that makes sense. Okay.
Other than that, it looks like everything else is very sparsely populated. And I'm not sure if this is sparsely populated or not.
Well, yeah, we don't know the units, right? I mean, it's population density 1250, but per what?
Per square kilometer.
Oh, is that what it said? Okay.
Yeah.
Oh yeah, area square kilometer. Okay.
So I'm not sure. Even then, I'm not sure 1250 per square kilometer. If that's 71 per square kilometer, I think is sparse. I'm not sure about 1250. All right. Which three prefectures have relatively higher density than the others? Are they spread throughout the country or all located in roughly the same geographical region? If you're unfamiliar with Japanese geography, you might find this map useful to answer the question. Well,
I think we can safely answer this.
Yeah, we answered that these two and this Osaka are the same. It doesn't look like this and these two are in the same geography, but not really sure.
Well, they're on the same island, at least, but yeah. But that's about it, yeah.
What is the solution for this? Tokyo, Kanagawa, and Osaka Daigo. All of these prefectures are located in central Japan, and Tokyo and Kanagawa are adjacent. So central Japan. Okay. All right. Which high density prefecture is prone to high magnitude earthquakes? Your map should visualize both density and earthquake magnitude. So we have this map. So we do still need this.
Yeah.
Because we do want to see the population density. But what we also want is earthquake data. So do we want a heat map?
I think we just want to do the, I don't know. What data do we have? Are they giving us for this? Sorry, I missed it.
They don't give us any data for this one. They are just basically like create a map that shows the one prefecture that might benefit from earthquake reinforcement. Your map should visualize both density and earthquake magnitude.
Okay.
So
yeah, then we
earthquake,
probably just want to, put the two together. So we probably want our heat map. Yeah, I would guess our heat map would probably be good.
Or we can do this.
With magnitude.
Yes.
Oh yeah, that might be good too. Yeah, that'd probably be even better. Good point, Robbie. That's good. We don't need the from, I don't think. The import, I mean.
Oh yeah, we already imported that.
Yeah. The rest though is good for sure. And instead of depth there, we're probably going to want to change it to magnitude.
Okay, we do need to check what's the range again. So
well, it will probably be between I think it's what, about 3 or 4 and 9. I don't know if there's been any 9s in recent history. I feel like we would have heard about it. Okay, 9.1, yes. And that's pretty severe.
Yeah.
For those of you who don't know, okay, 6. Okay, for those of you who don't know, magnitude scale is logarithmic. So a 9 is 1,000 times more powerful than a 6.
Yes.
So there's a big difference.
And you can see the impact when a 9 occurs.
Yeah, when a 9 occurs, cities have a lot of trouble staying upright.
Yep. 6, 7, well, light orange, I guess.
Yeah, if there is. Well, yeah, there's a list somewhere, but we could try it and see what happens. It should be pretty intuitive, but it might be LT orange. I don't know for sure. And then maybe yellow.
Oh yeah, actually that might have been better.
Oh yeah, we could. Yeah, that's true. Well, but we only need that. Yeah, we only need this. It's fine too. So.
All right. I think that should be it.
Yeah, that should be reasonable. Let's give it a try. Oh, did we add them to both the same map? And we use depth again, so.
Oh.
That's okay. We can fix it now. But may as well see what comes up. Yeah, I see one orange, one lonely little orange there. Oh, a few. Okay. Yeah, we probably won't.
Yeah, because all of the depths are going to be. I think everything just came into the last one.
Yeah. Exactly. I agree. All right. Let's see what you got here. Okay, so yellow was, how did that work again? 6 to 7. Okay. Oh, so we're never gonna see a forest screen.
Oh okay, yeah, so, we are never going to see it.
Yeah, we're not gonna see them very often. Maybe put 6.5, 7.5, 8.5. That might be good.
Yeah.
Just I mean, you wouldn't necessarily do this in real life, but it's just for our purposes for right now. Again, I like the idea of a continuous one, but it depends on what you're trying to achieve. So whether you're doing exploration or actually trying to tell someone something.
Yeah. Continuous with a sort of a scale. All right, so let's see. So anything less than 6.5, so 6 to 6.5 is green. 6.5 to 7.5 is yellow.
Mm-hmm.
And 7.5 to 8.5 should be orange, and 9 is red. Where is 9?
Don't know. Yeah. Oh, there you go. So are we trying to say which high density region needs the most earthquake reinforcement?
Yeah, so the three that we identified as the highest population density, which one of those would we recommend for getting more, I don't know, earthquake reinforcement in their buildings?
Well, based on the positioning of the earthquakes, I think tsunami protection would probably be a better investment. But if we zoom out, which isn't surprising, it's Japan. That's definitely a big issue.
Yeah.
But if I had to pick between Osaka and Tokyo, I think I'd pick Tokyo.
Yeah, Tokyo has a lot more earthquakes close to it.
Yeah, definitely up northeast of it for sure, and then Osaka's are quite a ways further away.
Yeah, so I think Tokyo. Let's see. A number of earthquakes.
Mm-hmm.
Good. And the long coast of Kanagawa.
Yes, and we even talked about the tsunamis too. So yes, having lots of unprotected coastline is important, especially with all of the offshore earthquakes that happen.
All right, they went with the same thing. Oh, they went with the radius to be
okay.
Magnitude. That's actually not a bad idea.
That is a good idea.
The radius increase.
Yeah, okay. That's cool.
That's a good method of denoting what's happening as well. So
that's one way to get a continuous scale too.
Yes.
Or at least a more continuous scale. Okay, that's cool.
All right. I think we are at the end of our exercise. And the next time that we come back, we are going to discuss geocoding. Learn how to convert names of places to geographic coordinates with geocoding. You'll also explore special ways to join information from multiple geodata frames. All right. Thanks, everyone. This was a fun exercise. It seems like we have taken a look at a lot of earthquake data now. We should all become geologists after some time. Or I don't know what earthquake is called. But all right. Thanks, everyone. I will see you guys next time. Bye.
See you later.